Welcome to Master Mathematics in Minutes. Today's topic is about the Pythagoras theorem, and we'll cover a couple examples on how to apply the Pythagoras theorem. And we will conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is the Pythagoras theorem? The relationship between the three sides of a right-angled triangle or right triangle is given by the Pythagoras theorem. Let's consider this visually. We have a right-angled triangle or right triangle, and the side that is opposite the 90-degree angle is called the hypotenuse. And we'll label that side as A. And we'll label this side as B, and the remaining side of the triangle as C. So the Pythagoras theorem states that A squared is equals to B squared plus C squared. So A is the hypotenuse, and it's the longest side of the triangle, and that is equals to B squared plus C squared. In the first example, we're asked to consider the following right-angled triangle, and we're asked to calculate x. So x is the hypotenuse of the triangle, because it sits opposite the 90-degree angle, and it is also the longest side of the triangle. So according to the Pythagoras theorem, x squared is equals to 3 squared plus 4 squared. And x squared is equals to 3 squared is now 9, and 4 squared is now 16. So x is equals to the square root of 25. And x is equals to 5 centimeters. In the second example, we're asked to consider the following right-angled triangle, and we're asked to calculate x. So the hypotenuse of the triangle is this side. It's opposite the 90-degree angle, and we're given that is 75 centimeters. And we're also given this side of the triangle, which is 50 centimeters, and we're asked to find x. So according to the Pythagoras theorem, 75 squared, which is the hypotenuse squared, is equals to 50 squared plus x squared. So we'll rearrange this equation. We have x squared, and we'll bring the 50 squared to the other side, and that becomes minus 50 squared. And we'll copy the 75 squared as is. And so x is equals to the square root of 75 squared minus 50 squared. And that gives us x is equals to 55.90 centimeters. In the third example, we're asked to consider the following right-angled triangle, and we're asked to calculate x. So we have two triangles, and both of these are right-angled triangles, or right triangles. So we have y as the hypotenuse of the first triangle, because it's opposite the 90-degree angle. And similarly, for the second triangle, we have x as the hypotenuse of that triangle as well, because it sits opposite the 90-degree angle. So according to the Pythagoras theorem, y squared, which is the hypotenuse squared, is equals to 10 squared, which is that side squared, plus 9 squared, which is this side squared. And simplifying that, we have y squared is equals to 181. So that is the first application of the theorem. And we'll apply the theorem a second time. So x squared, which is the hypotenuse of the second triangle, is given by 17, which is this side squared, plus y squared, which is this side squared. And so we know y squared from above is 181. So x is equals to the square root of 17 squared plus 181 by substitution. And so x is equals to 21.68 centimeters. In the fourth example, we're asked to consider the following right-angled triangles, and we're asked to calculate x. So once again, we have two triangles, one in blue and one in grey. And we're asked to calculate x, which is this side. So we have 9 centimeters as the hypotenuse of the first blue triangle, because it's opposite that 90-degree angle. Similarly, we have x as the hypotenuse of the second triangle, because it sits opposite the 90-degree angle. So according to the theorem, 9 squared, which is the hypotenuse squared, is equals to 5 squared, which is this side, plus a squared, which is this side squared. And so solving for a squared, we have a squared is equals to 9 squared minus 5 squared. And that gives us 56. So we've applied the theorem once. So apply the theorem again the second time. So with x squared, which is the hypotenuse squared of the second triangle, and that is equals to a squared, which is this side squared, plus 32 squared, which is this side squared. And we know from above that a squared is 56, so we'll substitute that in here. So that becomes 56 plus 32 squared, and that is 1080. And so x is equals to the square root of 1080, and that is 32.86 centimeters. To summarize, the relationship between the three sides of a right-angled triangle, or right triangle, is given by the Pythagoras theorem. So visually, we have a right-angled triangle, and the longer side of the triangle is opposite the 90-degree angle, and we'll call that the hypotenuse. We'll label this side as A, and label the two remaining sides as B and C, respectively. So according to the theorem, A squared is equals to B squared plus C squared. So the hypotenuse squared is equals to B squared plus C squared. Thank you very much for watching. This is Master Mathematics in Minutes.